this project, we are going to see a survey on comparing machine learning algorithms to improve efficiency of IPv6 network. Introduction. On the internet, each computer is identified by its own IP address. The current IP addressing system based on IPv4 is insufficient for addressing billions of computers. To address this, IPv6 with a 128-bit length was introduced. This technique was used with machine learning classification clustering algorithms, but this technology could not accurately predict IPv6 address when attacks are launched because the algorithms are not trained to learn on their own. Objective of the project. In order to learn from its surroundings and give fresh IPv6 addresses to nodes if they feel slow or attacked, the project employs reinforcement learning. It uses an algorithm with environment, agent, and actions. When addresses are already generated or are being attacked, the agent monitors the environment and runs the action function to generate new addresses. If successful, the reward increases, and not, there is a penalty. These are the requirements needed to execute this project. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is number of nodes. In this module, we have to enter the number of simulation nodes to be created. The second module is node ID. We have to enter node ID here as an integer value. The third module is initialize number of nodes. Using this module, we will create and initialize given number of simulation nodes, and each node will have its own ID as integer value. The fourth module is IPv6 addressing using reinforcement learning. This module runs reinforcement algorithm to set up environment and then ask agent to generate new IPv6 address, and if address is assigned successfully, then agent action will be rewarded, else penalty will be applied. The process continues till all nodes get IPv6 addresses. The last module is rewards and penalty graph. Using this module, we will plot graph of rewards and penalties. Execution of the project. To execute this project, first we have to open the Python code folder. These are the Python main code files. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. In this first module, that is number of nodes, I will give the number as 30 and node ID is automatically selected. Now click on initialize number of nodes. Red color circles are the nodes and blue color circle is the base station. We can see there are 29 nodes created and one base station created. Now click on IPv6 addressing using reinforcement learning button. We automatically assign 128-bit long IPv6 address to each node using reinforcement learning. We can see the node ID, the previous node ID, and the IPv6 address in the text box. Now click on rewards and penalty graph button. In this graph, on x-axis we have total iterations, rewards and penalties. On y-axis we can see the number of iterations done. In this graph we can see total number of iterations and total number of rewards and penalties secured from these iterations. Close this tab. Now click on exit to exit from this tab. The conclusion here is the reinforcement learning algorithm will call automatically in real environment when node data transfer is slow or attack generated. The project utilizes reinforcement learning to automatically assign IPv6 address to nodes when they experience slow or attack data transfer. This algorithm monitors node IDs and assigns IPv6 addresses, ensuring rewards and penalties.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.